Tout, 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 tout. Hmm. Waouh! Rien de là. Um, tac. Right. Okay. Just remove all AI note taker as usual. And yeah. So I'm gonna put a message.
Hello, sorry.
Hi,
Hi. How are you?
great. It's like a sunny day on my side, so
Yay. I think winter is over, no?
yeah, I think so.
Okay. I think so. Are you going to ECC? Yes? Okay.
Of course, and you?
No,
Why?
I don't know. Maybe just Dev Connect, but not ECC.
Yeah, everyone's going to disconnect.
Yeah, but it's too far for me. I don't know.
Argentina. Mm,
Yeah,
I know.
very far.
Yeah, and you have to deal with visa process or not?
Yeah, exactly. I have to apply for a visa. But I think it's easier than, like, let's say the US. I
Mm.
mean, the US is horrible. Yeah, for sure.
Look,
Hello, hello, everyone.
just put a message. All right, we're gonna wait 2 minutes, something like this, I guess. Oh,
E.
oof. Let's see. I know some members will fly from next week in London to participate to the Avalanche Hackathon. So that's
Oh,
nice.
yeah. Woohoo!
Yeah.
Congratulations.
And I heard something about more Ethereum hackathon itself is like
Hmm.
uh, actually Ethereum organizer um
Hmm.
stuck to really attract partners just because um it's too much farmers uh
Oh,
into the Ethereum ecosystem. Yeah. Um
really?
yeah, too much bounty hunters and so on, and so basically they didn't find any return on investment for the moment. So yeah, I heard about it today, that the EVM hackathon are starting to go like this.
No way.
Yeah.
I didn't know that. That's crazy.
Yeah, but Ethereum Foundation didn't put any efforts to onboard new people. They are just focused on the tech side. And then that's why, like, I think from next month, I will try to push them to to really understand that, because otherwise, um, uh, like, some people are going to, for example, Solana and so on. But
Yeah, it's a missed opportunity.
mm, yeah, yeah, yeah,
That's crazy.
exactly. But let's see, this year, um, mm, that's sad for them.
Should we start?
That's sad for them.
Ah, yeah, exactly. I see a lot of talks on Twitter about this,
Mm.
but I don't know where it started from.
From the leadership, the
Okay.
Ethereum Foundation leadership. Yeah.
They posted something.
Um, yeah, it was on December or something like this, and then that's why they changed.
Mm, the leadership.
Yeah, but let's see, something will happen. But I will talk with them later.
Yeah, that's pretty sad.
All right. So I guess let's start. Um, so I put like wait. Telegram, where is it? So can you
Wait, I think I'll turn the AC on 1 minute.
la 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 la. Yes, I put a message like a poll. Yes, a poll on Telegram, asking if you have completed the section one of ciphering, and don't hesitate to reply to it. And then it's great to follow up everyone, and then if you have any issue, don't hesitate to ask question too. All right.
I'm back. You were talking to me.
No, to
Okay.
everyone, no reason. That's fine.
All right. Let's start then.
Yeah, so to precise, um Khawla is really specialized into this area.
Yeah, oracles? Yeah. I guess so. So if you have any oracle questions, hit me up. Let's go. Um, so today we're actually gonna do the FundMe project, and then at the end we'll talk about oracles a little bit. So I think section 1 and section 2 were covered
Yes,
in the last 2 sessions. Yes,
exactly.
exactly. So now today we're gonna start with the FundMe section. And we're gonna look into the FundMe project, and wait, sending E through the function. Maybe I skipped this section, I guess. And then we'll look into Solidity reverse and also an introduction to oracles. Did someone say something? No, you're just sending it. Okay. So, let's start here. We want to build a project in Solidity, which is like a Web3 crowdsourcing application. So you want people to fund your project, and this contract will be a way for you to raise money. So
Oh, by the way, during hackathon, I saw a lot of projects doing this kind of things. So it's clearly too common. So don't do this kind of of project
project.
during the hackathon, because it's too, yes, too common.
Yeah. Well, okay, that's a good thing to take care of. And yeah, so then what we want to do is to allow users to send the native cryptocurrency of the blockchain to the contract. However, you want to say that the minimum fund should equal to $5. So now there are some questions or challenges that you might have when you're trying to set up a project like this, right? So what are the questions? First of all, I want people to send me money, but then how do you send money to a contract? How do you send ETH to a contract or any native cryptocurrency? And then if somebody sends me money, how do I access that value? Where is it going? And then, yeah, like how can I use it? And then and then one of our requirements for the project was to accept a minimum of $5. But then how do you translate that? How do you like convert Ethereum or ETH to dollars and then figure out the calculation from there, right? Because they're gonna send you because the contract only accepts the native currency, and sometimes tokens, like it does accept tokens. But let's say that the contract that we will set up will accept ETH, it will take ETH, and then you're just not sure how to check the price of ETH in terms of dollars. So this is where oracles come in, and which we'll talk about later. And then let's say they don't send the right amount to you when they're trying to fund your project. What can you do in this case? How can you not take money from them? How can you stop that process and revert, or just not like you don't allow the function to continue executing? So these are the kind of challenges or questions that you might have when you're trying to set up a FundMe project, right? So let's see how we can do that in Remix. I'm gonna open up Remix now. I'm sure by now everyone's familiar with Remix. That's a good thing. Okay, I have my Remix open and I hope everyone also does. Let me delete this. Now, if you remember, you start by creating, you create a contract by starting to create a file. Like you initiate a file and then you call it fundme.sol. You give it this .sol extension. And then you need the license, the Pragma, or like the Solidity compiler version, and then the contract keyword, which should match the contract keyword and the name of the contract, which should match the name of the file that you have here. So let's do this. We'll say, I'll use this from my previous contract. This is the license identifier. This is a Solidity version. Again, we're saying that this contract can be compiled using Solidity compiler version 0.8.13 and above. So if they're rolling out a 0.8.30 compiler, you can still use that to compile this contract. And then you say contract, and then you call it FundMe. And this is where it starts to get interesting. I hate when AI starts suggesting stuff, like, please. No one asked you for anything. Let's say, where do we start? Okay, let's start with declaring the function fund. This fund function will not take any variables. It will not have any parameters, and it will be public. And now this is the interesting part, is that you can mark it as payable. This is a payable modifier. And what this means is that this function can receive ETH. It can receive money, like you can transfer stuff to it. So payable allows the function to receive Ether together with a call. So you call the function fund, and you also pay for it at the same time. And then you can use this to either, for example, one of the use cases for payable is, let's say you want to charge someone a fee for calling this function. For, again, in terms of oracles, let's say you are requesting for the current price of Bitcoin in USD. So then if it's a special type of oracle, sometimes you'll have to pay fees to fetch that price. So this is one way of using the payable modifier, either for people to like fund your project, for example, or for example, for charging people in using your services, for example. That because an oracle is kind of a service. And then let's see, so this is payable, right? And then we are trying, so we want to say that wait, how do okay, maybe we can start with testing the function, and then we can talk about the require statement. But before we get into require, let's see how this function would work. For now, I will just, let's say, uint 56, my value. And then it will just do anything for now. It will not, let's say it will assign 1 to my value, but it's not doing anything. I just want to test how this function will receive ether. Now you compile this contract and you deploy it using Remix VM. And here you have this function. So now this function is marked as payable, but how do you pay through Remix now? So one thing I like to talk about is the color codes in Remix IDE. If you see here, when it's marked as red, when a function is marked in red, that means it's a payable function. When it's marked in orange, that means it's not a payable function, but it's a setter function. And when it's marked in blue, that's a getter function. So it only reads values and displays them to you, but an orange function is a setter function. It changes, it updates the state variables essentially. Okay, so now this is a function called fund and it's payable. And I want to pass some ETH to this function. So how do I do that? If I just call it like this, let's see what's going to happen. It will get called, even though you didn't pass any amount. Why is that? Because you don't have any conditions set here. You're just calling it payable, but you can pay 0 ETH and it will be invoked. Actually, let's do public. Let's do this as public so that we can get a getter function, which we can access this value through and read. And then let me clear my terminal. Okay. I'm gonna compile FundMe. We'll redeploy. And then let's see what happens. You call my value, it's going to be 0, right? Because we didn't do anything with this variable yet. But now let me call fund without passing any ETH. And like we saw a few minutes ago, I was able to call the fund function, even though I didn't pass any ETH. And then if I read my value, is it going to be 1? Let's see. Yes, so it got updated and now my value is equal to 1. And so just because you marked a function as payable does not mean that you have to pay for it because it can be 0 ETH. So then how do you put a condition there that says, no, you can't give me 0 ETH. It has to be non-zero, for example, or it has to be greater than 1 ETH. Like I need at least 1 ETH, or not even at least, like above 1 ETH. So how would you say something like that in your function to avoid people sending 0 ETH to you? So the way that you would do that, oh, but before we go there, let's see how we can pass ETH to this function. You're gonna go here to this value field, and you're gonna switch to Ether, and you will pass one Ether, and then you click on the function. So you set how much you want to pass and in which unit, and then click on fund to see. I'm not sure if it shows you. Yeah, it shows you there's a value that has been passed to this contract, and it's this much of Wei. And now you wonder, what is Wei? What is ETH? What is Gwei? So let's talk about that. Those are the different Ethereum units. So because ETH is so big, like right now, 1 ETH is like what, $2,500, I guess. ETH is like a big number, and you don't always deal with values that are this big, right? Like sometimes it's only a 0.0001 ETH, for example, that you're dealing with. So in order to represent smaller units of ETH, you have these Ethereum units. So 1 ETH, let's see. Look here. 1 ETH is equal to, what is it equal to? 10 to the power of 9 Gwei, and then 10 to the power of 18 Wei. So Wei is the smallest denomination of Ether, or the smallest unit, and then Gwei comes before Wei, and ETH is the largest unit. Usually Wei is the unit that is being used in the smart contract. That's what we deal with. And then Gwei is used for gas. So if you look at a random transaction on Ethereum, for example, this one, you will see that the gas price, the gas fees, are all in Gwei. So usually gas prices so usually Gwei is a unit for gas prices. And then when you're writing smart contracts, you deal with Wei. Yeah. So then we see here, we were able to call the fund function. We were able to pass a value or a money or an amount to the fund function just by giving it a payable modifier. And then we were also able to see that even if you send 0 ETH, you can still execute this function because you don't have any conditions on the amount. So then now the next step becomes, how can we put a condition that says, hey, I only accept this amount of money, and if you don't give that to me, then you're not allowed to update the state variable, my value, for example. So to do this, we will use a require function. So let's talk about validations. So there is, it's not a function. Is it a function? No. I mean, yeah. So it's like a validator that you call require, and then you can either pass a condition. No, like you can define the condition, and if that and that condition can be either true or false. It can be Boolean. And then based on that, it will abort the execution of the function call, and it will revert the state changes if the condition is false. But sometimes you also want to abort the execution of the function while also printing a message that can show up in your terminal and maybe like explain what happened and why it failed or why it reverted. So that's something that you can do. There are two ways to use require here. And then there's also revert. Revert does not, there's no condition that you can pass to revert. So that's the difference between require and revert. Revert will just revert like immediately. Like you can, for example, use it in an if statement. You say if something, then call revert. But with the require, you don't need to set up an if statement, for example, because like you can just put the condition inside it. And then revert can also take a parameter, which is the message. That's the only thing that it can take. And they both abort the execution and they both revert the state changes. However, require takes a condition. So let's see how we can use that here. Let's say with every call, I want to increment, I think just so that we can observe what happens to the state changes, we'll do my value plus 1 every time the fund function is called. And now we will introduce require statement here. And the require statement will use something or access something called message.value. And it will say that the message.value, and because we're passing 1 ETH, and that is the smart contract deals in way. So we're saying it should be larger than 1 ETH. So that means 1 E18, right? 10 to the power of 18. And then the message will be, you didn't send enough ETH. Okay. So message.value is, so like in a transaction, in a function call, right? You will have like, you will have a message object, and within that message object, you can access different things. So we will use that. We will use message, and then we'll message object, and we'll access value, and that will show you the amount of way that it is being sent when somebody is calling your function. And this is a globally accessible variable, so that means you can use it anywhere in your contract. You can access it from anywhere in your contract. So that's what we're doing. So we're saying, hey, look at this function call, fetch that value, which will be available in the message object, fetch the value that they're passing to my contract, check if it's larger than 1 ETH. Remember, 1 ETH is equal to 1 E18, which is equal to 10 to the power of 18 way. Okay. And then if this condition is true, if it's larger, then it should continue executing and everything is fine. But if it's false, then print this message, didn't send enough ETH, and cancel the whole state variable update. So what does that mean? That means that if my value, so if you are updating my value and you go into this function, you say my value is equal to my value plus 1, and then it comes here, it checks that you didn't send any ETH, it will cancel the state update here. It will cancel the changes That's it's made in this part. Yeah. So if you're incrementing it by 1, let's say if it was at what if it was my value equals to 1, and then it enters this function, and then now it becomes 2, and then it checks the condition in the required statement, and it's false. So then my value goes back to 1. So let's see how that looks like.
A question.
Yes. If it's not bigger than 1, no, it will revert, and it will show this message, didn't send enough ETH. Let's try it together. Deploy the contract. And my value is at 0 now. And we will pass, how much should we pass? Let's pass 0 ETH. Yeah. Can we do decimals? I don't know. 0.1? Yeah, no, you can't. What if I want? Can we use way for that? No? Anyway, let's not complicate things. So let's say I'll pass 1 ETH. No, let's pass 1 ETH, because in the condition, I'm not saying greater than or equal. I'm just saying greater. So then I'll call fund. Reverted. So it says didn't send enough ETH, which is exactly the message that we told the function to throw when this condition is not satisfied. So then let's try sending 2 ETH. Is it gonna work? Oh, yeah. Oh, actually, let's see my value. My value is still at 0. You see? So even though it started here, right? It starts with adding 1 to my value, and then it comes and checks it. But no, everything that you've done within this function will get reverted, will be canceled, and it will go back to its original state. That's the whole purpose of a required statement. Yeah, so let's pass 2 ETH. Let's fund let's pass 2 ETH as a value, and then I'll call fund now. And you can see the balance here also. This whatever ETH that you're receiving goes into your contract. So even your contract itself can hold money. Sometimes I guess, not sometimes, but it's a good practice to have a separate address where, let's say, your funds will go to. Like, don't store funds on a contract. Like, put them in a separate wallet. So as you can see here, my balance is now at 2 ETH, and that means it got accepted. So then if I call my value, it should be 1. It's at 1. Let's go. So then, yeah, so this is how a required statement works so far. Any questions?
Don't see question.
Okay, cool. Nice. All right. So far we spoke about message.value and the payable modifier. You can also check here. Wait, what's that? Let's see. You can see all of the globally accessible variables in Solidity here. There's a bunch of things. You can access message.data, message.sender, which we use a lot, message.sig, transaction origin, block.number. So these are all globally accessible variables that you can use within your contract. So let me share this with you. We can go chat. Okay. Now, we spoke about Ethereum units. We spoke about the different validators, require versus revert. Now let's talk about oracles. Woohoo! So
A great
oracles,
path.
yeah. So the 1 minute.
Yes, in Dubai you need to drink.
Right? Yeah, the weather. It's insane. But yeah. So let's talk about the Oracle problem. And I took this quote from him, from Patrick, right? How did I forget his name? Wow. Shout out to Patrick. You're so cool.
But
Uh,
spelling,
if you see this, yeah. And Philly. Okay, that was funny. And so the Oracle problem said that smart contracts are unable to connect with external systems, data feeds, APIs, existent payment systems, or any other off-chain resources on their own. So then, like, what that means is that, let's see here. This is even better. So blockchains are deterministic in nature. So that means what that basically is trying to say is that you have all of these nodes, and if they can all come to consensus about, let's say, a single value,
I
they
think we need to make a brief introduction to nodes.
yeah, okay. So like no nodes are like if you have a blockchain, it's a network, and then within that network there are people that are running the same version of this network, right? And they're all connecting and syncing, and then they are all coming to consensus about the state. Let's say, for example, in my contract, my value is now at 1. All of those nodes should have all of those nodes should have my value equals to 1 at the same time. So they should all have the same values replicated everywhere. All have the same states. So that's how a blockchain should be. And so we call it deterministic, um, because if you give the same inputs, you should get the same outputs all the time. But now let's say one node is trying to access an API for, let's say, weather data. Another node is trying to access the same API, but then both of them would not be getting the same API, uh, the same weather value, right? So let's say it's 35 Celsius for one node, but then the other node calls the same API at the same time, and they might get, I don't know, 34 Celsius, for example. So then this is not okay because they should all have the same states. They should all have the same values replicated. So that becomes non-deterministic, which is not the nature of a blockchain network. So then who can help with this problem? Oracles, right? So then what oracles do is that they do the work. They go, they check the weather. They see, okay, on this website, on this API, it says 35. There it says 34. It says 32, whatever. Let's take all of those. Let's take all those data inputs. Sorry, all those data inputs, and then we aggregate them. We get a single value, and then that single value will be delivered to your contract. So that way everyone will have the same value of weather at this exact timestamp. That's what the Oracle is going to deliver to you, and everyone can access this value. And so blockchains are isolated, right? They don't know anything about the market data. They don't know what's happening in retail payments. I don't know, bank payments, like it says here. They have no clue what's happening in the outside world. So in this case, you would need oracles to communicate that to them, and deliver that kind of data, yeah, to your contract. So as you can see here, another big issue with oracles is that you can't rely on a single person, right, to deliver weather data for you. Like, um, it's not a good thing to just trust one person to deliver that data for you. And if I say, oh, I aggregated, um, I looked into those several websites and I aggregated this data and I'm gonna give it to you, you're you can't really trust me, right? Because it's just a single person doing this activity. So that's a problem with oracles. Centralization is a big problem, and we know a lot of oracles have been trying to solve this, and they are. And so there are many different approaches for decentralization. So then, right, yes. So then, even with Chainlink, they have their own decentralized Oracle network. I think it's called Decentralized Oracle Network. Dawn, yes, they have the Dawn network. And the Dawn network is essentially also multiple nodes, right? It's like think of them as multiple people looking at the same data sources, bringing that, aggregating it, and delivering it to you. Yes. So that is how oracles work. Let's see.
Yeah, it's a really crucial aspect in Web3 to get the outside information into
Exactly.
on-chain world. And then when you need to really be synchronized with, for example, a price or anything, you need to really rely on Oracle for that. So it's really, really crucial, especially on DeFi, by the way.
Exactly. Almost like a lot of DeFi applications use oracles. So it's not just, that's why it's every introduction to Solidity course, you would see oracles being mentioned because they are literally a key piece in DeFi. So a lot of DeFi applications rely on that to get the to get market prices, yes, of any asset. So this is an example of a Bitcoin USD price feed. As you can see, it says right now, Bitcoin in USD is at 100K, which is again crazy. And this is this is the last update time. So it will tell you, hey, the last time we updated this value and we fetched and aggregated the prices was 26 minutes ago. And then, okay, so when is the next update gonna happen? It's showing you right here. It's showing you the heartbeat in 33 minutes, I believe. At how much did you buy? I don't have BTC. Wow, bold of you to assume. No, I'm very broke.
Oh, right. I think it's like I don't know, when you start in Web3, like it's the first thing you buy.
Yeah, no, I didn't. I only bought like ETH, maybe.
Ah, okay.
Yeah.
A rebuy, it's like when it was at 2000. I
You
said,
bought
okay,
it
a
at
rebuy.
two.
Like,
Ah, Riba.
yeah,
No way.
yeah.
That's
When it's going
crazy.
like this, I'm the people who are going to buy.
Yeah.
Yeah.
Oh my goodness. Anyone else also has crypto?
I think it's a really good way to always try application because it's like this that you're gonna be familiar with the ecosystem and also build real um, application on your side. So
Exactly.
have a
That's really
budget,
cool.
like I don't know, $10 by month for testing
Yes.
application. It's
Yeah. And use Uniswap. I think like it's very user friendly and
yeah,
fun.
that's true.
That's true. Um, yeah, maybe a little, yeah, just to show you that we're also working on blockchain oracles and just to show you the decentralization part. Um, we have, uh, for example, this one, push oracle. We're using Hyperlane here. I don't know if you know Hyperlane, but it's like, so essentially like they produce we have like data feeders. The data feeders take the prices from the exchanges and different markets, and then what happens is they deliver it to like this what we call laser net, which is a roll-up. And then after that, there's a hyperlane bridge, which takes those values and deliver it. So just to show you that there are different ways to decentralize your oracles, and those solutions exist. So yeah, it's interesting. Look at the price feeds, look at these nodes, look at their responses, how everyone is contributing. That's very cool. It's a big, big world. And then maybe lastly, we can quickly talk about we can quickly talk about the aggregator interface. Any questions so far though? Aggregator.
No, I just want to mention that on June we're gonna have like a specific mini school um
Mm-hmm.
about more training for training
About what?
training,
Chainlink?
yeah. um
Amazing, yes.
they are running an hackathon, and then it's the main actually.
I signed up.
Oh,
Yeah.
nice.
Let's do a team, yes.
So it's the main um, oracle used into Web3 actually. So if you will be familiar with it, you will find every time changing into hackathon. So that's a great way to right now get into it on June. So
Yeah,
we'll keep you updated about it.
exactly. I think you also formed a team for another hackathon. I don't remember. For base, I think.
Yeah, for base hackathon
That
too.
was nice. Okay. Um, yeah, so then this is the aggregator v3 interface. We'll also, I believe, we're going to talk about interfaces at some point. Or maybe I should have. Hmm. But essentially, interfaces are like the blueprint for your smart contract. I think we will dive into it in some later session. But to use wait, change data feeds, price feeds, learn how to read. Okay, nice. Open a remix. What happened? Yeah. So to see this is an example of a contract that is consuming a chain link oracle. So you can see here, it's passing. So every price feed, let's say BTC, ETH, they all get their own aggregator contract. And you can see those list of contracts in the documentation. Then you can pass it to the constructor, and then you can call latest round data. Yeah, so you can call latest round data on this contract, on these aggregator contracts, which will give you the latest answer, which means that's the latest value of Bitcoin and USD. So as you can see, it's pretty simple. You can also get the timestamp and other parameters that you would need. But essentially, it just needs to import the aggregator v3 interface and then pass the aggregator contract address to that interface and assign it to this data feed value. And then from there, you can read. Is it casting that you do? Um, kind of like, yeah, similar concept. Yeah. So, so when you do this, it allows you to access the methods on the contract.
I remember Ashley was pretty new, like 3 months ago about Solidity stuff. And right now
Really?
she was asking some question. Yesterday she helped Raquel as well. So pretty
Oh,
lucky to see that. Um,
yay.
Share your advice. Yeah. So
Amazing.
that's
That's great progress. Wow. All right. So I think we are done. So try it out. Try different price feeds. This one is on Sepolia. I know Sepolia can be annoying sometimes, but there are like other networks. Not sometimes, all the time. And yeah, so this is what we covered today. Let's do a quick quiz. Quiz time. Drum rolls. Test your knowledge. There are three
question.
questions ahead of you. Sorry?
No, I said three questions. Yesterday it was like eight questions, something.
No way. Shit. Okay. Let's start. What is the correct relationship between Wei, Gwei, and Ether in Ethereum's unit system? Who can answer? 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D.
They say they D.
Yeah, I also say D. Let's see. Hey, good job. Next question.
Take the, like be
Drum rolls.
magician, a magician.
Yeah. And then what is the purpose of the revert action? A revert action allows you to undo the most recent state change on the smart contract when called, or a revert action allows you to undeploy, that's wild, a smart contract, or a revert action stops execution, but keeps all state changes up until that point, or a revert action undoes all prior operations and returns the remaining gas to the transaction sender. Which one?
You will see a lot of this kind of thing on your side.
Yeah. We have people saying D, people saying C. How are we feeling about this? Okay, so we all agree that B is not correct. Like definitely it does not undeploy a contract. So then we're left with A, C, and D. A, revert action allows you to undo the most recent state change on the smart contract when called, or it stops the execution but keeps all state changes. Does anybody agree with this? That it keeps the state changes? Remember when we were testing my value and then we called my value when it reverted and my value was still at 0, right? So then no way that this could be possible.
Oh shit! I would say this one.
You were saying this one? No, Celine. You get a D on the test.
Oops.
Oh God. Okay, so then we're left with A and D. Okay, I see two people said D, and I also think, wait, a revert action undoes all prior operations. No.
The thing is,
Oh,
like, I'm not sure
it's
about
A. I
yeah,
think it's A.
because like the fact that the gas is returning to people is like
I wish, right? Yeah.
not happen.
I would be so happy. Yeah. I would break all of the functions just to get my money back. So yeah, I think it's A. Let's see. Oh no!
All right.
Wait, okay. It returned the remaining gas. I didn't know that actually.
Yeah, me too.
Wow, Sunday, thank you. Also, Asli, both said D. Awesome, okay. I actually didn't know that it returns the remaining gas. Maybe I need to go back to Solidity docs. Good job. Let's see. The third question is, which keyword is used to allow a function to receive native blockchain tokens such as ETH? Which one? We spoke about this. A, correct. Payable. Woohoo! Yay, congratulations. This is the end. Congratulations to all of my Solidity nerds. Woohoo! We are done with the quiz. Hopefully you got all three right. Don't mind me. And that's it. We are done. I think for tomorrow, we're gonna do libraries. We're gonna see how to fetch from Chainlink, which is so cool. What else, I think? I don't really remember, but
We need to
yeah.
revise.
Yeah, that's step number one. We all spend 3 hours on Solidity docs. Oh
Yeah, on
God.
my side, I think like I just did the first section or something like this. I was not going to like further. Yeah,
Yeah,
I think so.
just this section.
Yes,
Okay, you still have
I was
Thursday
on
and Friday.
I
Yeah.
was on the Solidity bootcamp with Angan Club before, so
Ah, okay, perfect. So
yeah.
then you don't really need this. I
That is a
see.
great way. It's a great way to go to Cyphin, also to revise. And yeah, so, sometimes some change can happen. So yeah.
Yeah, exactly. I also forget a lot of things all the time. But you shouldn't. Don't be like me. Mm-mm. Yeah. All
Alright.
right. Cool. We're done. Thank you all. This was fun.
Thank you for your involvement this week with us.
Yay. Of
Yeah,
course. Hearts, hearts.
yeah. Ah, something. Uh, like I will send your X account.
Oh, yes. Feel free to reach out on Twitter, the bird app. How do you do bird noises? Maybe I shouldn't try it here on a live session.
The what?
Bird noises. Like a meow, but like birds. Like how do you? No,
There's not even.
so funny.
Don't.
No, no, no.
All right.
That's not a bird. Yeah. Well, thank you for trying.
I can do something else. I can.
Yeah.
It's
What did you do?
like for dog.
Yeah. Oh, you can bark.
Yeah, it's a talent. My only talent.
No way. Hidden talent. Wow. We
Yeah.
should do like a hidden talent session at the end.
So, all right. Thanks
All
again
right.
for everything. And yeah, let's keep in touch on Telegram if you have any question. And revise everyone, even myself.
Yes, me too. Guilty.
Yeah.
Thank you all.
Thanks again. Bye bye.
Take care. Bye.